Here we go. All right, so well, let me share my screen one more time just in case. There we go. So remember, we've been talking about derivative rules, and yesterday we went, not yesterday, you know what I mean, Wednesday, we went over the chain rule a little bit more. So we have two more from the chain rule that we need to finish up before we talk about our last two rules. And then we'll do a couple different types of examples that show up on your homework, the Wiley one specifically. And that'll do it. All right, so for number 5 in this chain rule section, so remember, essentially we have kind of 3 options for our chain rule. The outside, is it something to a power e to the something or natural log of something? So for this one, I start with essentially this chain rule that has, I forgot to turn this on. Let me scroll up the tiniest bit. There we go. So we essentially start with a chain rule and then have 2 kind of not chain rule pieces at the back. But remember, when they're addition or subtraction separated, you just take them one set at a time. So the first thing we need to deal with is this chain rule, which is essentially a natural log of something. Remember, it's okay up to a constant. So that constant, that 5, is just going to kind of tag along. And then we take care of the natural log of that 2t squared plus 2. So remember, for the chain rule, it says the derivative of the outside. So what's the derivative of the natural log of something? Well, that's 1 over that thing. So we'll have 1 over 2t squared plus 2. But then I have to take the derivative. So we've essentially taken care of the 5 in the natural log, but now we need to take the derivative of the inside. So the 2t squared plus 2. I'm going to start to stop writing some of the intermediate steps. So this would technically be 4t squared plus 0. What is freaking out back here? I don't know what's going on over there. Anyway. And this is falling. Oh, I'm sorry, it would just be t. I'm sorry. Because yeah, subtract 1 from the power. Okay, let me not skip my intermediate step then. 2 times 2t to the first plus 0. So the 4 came from the 2 in the front kind of sticking around, and then the extra 2 that we kind of bring down from that power is where the 4 came from. So if I wanted to, I could simplify this a tiny bit by multiplying that 5 and essentially that 4 to get 20t over 2t squared plus 2. Oh, I'm not done. Oh my gosh, now I got panicked by things freaking out. So that was just the derivative of that first natural log piece. So we had to take the derivative of that natural log and then the derivative of the inside. So 2t squared gave us 4t, and then the plus 2 essentially gives us 0. And then I have to add on the derivative of 7t squared. So that's going to be 14t, coming from 7 times 2t to the first. And then minus the derivative of 9, which is 0. So our final answer would just have an extra 14t tacked on at the end. I got to through that one and mess that up a little bit. There we go, though. Any more questions, concerns on that one?
Wait, I'm sorry. How did you get 14t?
Yeah. Whoa, what happened? Did y'all screens just go black? What?
No.
No? Both of mine did. That's weird. So y'all can still see?
We can see the notes, but not you.
Interesting. Okay. Both of my screens are completely black, except for the one that I have my notes on. But if you can see it, then I'll just keep going, I guess. So the 14t squared, so if we start with 7t squared, then the 7 kind of comes along for the ride, and then the derivative of t squared, we bring the power of the 2 down and subtract 1 from the power. So then the 7 times the 2 is what gave me the 14. Where did I get the 22? Yeah, so that came from, let me just erase this. So essentially, this first piece If I rewrite this 2 times 2t, I get 4t. And then I can essentially multiply the 5 and the 4t to get 20t, and I can kind of just put it in the numerator because I can. Being able to see the screen, let me try doing this. Come on. Or it's just gonna freak out. Oh dear, everything's broken. Give me 1 second. Try this one more time, and if it doesn't work, then it just won't work. There we go. Okay, that's so much better. Okay. Any more questions on how I got anything from that one? Let me clean this up a little bit. All right, so number 6, we essentially have 2 chain rules going on, and they're separated by subtraction, so we just have to consider them one at a time. So the first one we come across is the derivative of e to the x squared plus 7. Let me scroll down a little bit so we get our kind of tip in there. The tips that we have down there. So the first thing we need is the derivative of that. Oh my goodness, something's wrong with me today. Is we essentially have e to the something, so that 2 in the front's just kind of sticking along for the ride. And then if we need to take the derivative of e to the something, remember, well, that just stays itself. So we have e to the x squared plus 7. But then I have to take the derivative of the x squared plus 7. So the derivative of the x squared plus 7, we get 2x plus 0. So really, I don't need to write that plus 0, so I'm going to erase it. Which takes care of all of our pieces for that first chain rule. I've taken all of the derivative pieces that I need. So then I just need to subtract the derivative of this 5 natural log of 2x minus 1. So the 5 kind of comes along for the ride. And then if I have the natural log of something, the derivative of that is that we start with the 1 over something. So 1 over that inside of 2x minus 1. And then I have to multiply by that inside, the derivative of the inside. So the derivative of the 2x minus 1. So the derivative of 2x is 2. Minus the derivative of 1, which is 0. So I'll write it and then erase it, because we don't need to write it. Again, if you like to write the minus 0 stuff, go right ahead, but you don't have to. I could simplify this a little bit, but also remember that this would be a perfectly acceptable answer. I don't ask you to simplify, everything's breaking, simplify these at all. But I could simplify these if I multiply the 2 by that 2x in the back. I would get 4x e to the x squared plus 7. And then I could multiply that 5 and that 2 to get 10. Put it on the top of that fraction to get this. But again, perfectly fine for you to just keep it at the line above if you want to. Questions, concerns about that one or the chain rule in general? Go on to our last 2 rules. I don't know what's wrong with my speaking today. All right, so we've got 2 last rules that we need to talk about. They're the tiniest bit similar to chain rule because all of the other rules are kind of encompassed, like work within these rules. But these ones are slightly nicer because they follow a bit more of a set pattern than chain rule did. So we have the product rule and the quotient rule, which is essentially going to tell us how to take the derivative when we have 2 functions that are multiplied together, and then the quotient is going to be for when we're dividing them. So, excuse me, the product rule tells us that we essentially take the derivative of the first function and leave the second function alone. And then we add that to to the first function left alone times the derivative of the second function. A lot of times I'll just write this as f prime g plus fg prime and just like drop all the of x's because they get a little tedious. But now with this one, if you were to do like g of x times f prime of x and then g prime times f, that's perfectly fine. You can multiply these in whatever order you want to. But anyway. And then our quotient rule, so when we have one function divided by another, and this tells me that this is equal to, now this one's a bit larger, so leave yourself some space. So we still take the derivative of the first times the original second, but now we're going to subtract the original first times the derivative of the second. So it's like a very similar setup to the product rule. It's just that now it's subtraction instead of multiplication, addition. But then also we get this extra piece of dividing by the g of x all squared. So I'll wait like 5 more seconds for y'all to write that down before we do some examples. So this first one for product rule is kind of used to just demonstrate that it actually does what it should. Because if you think about this, x times x squared is technically x to the third. So if I were to take, you know, its derivative, if I were to find f prime, it would be 3x squared. So we're hoping that the derivative of x times x squared is going to be 3x squared. One thing I like to do is I like to kind of come off to the side and find all the pieces before I kind of bring it all back together. So since these always include an f and a g, I kind of come off to the side and write down all of my pieces and then kind of glue it together. That's not necessary. You just want to talk yourself through it, say the derivative of the first times the second plus first times the derivative second, and you just want to write it out as you figure it out. That's perfectly fine. But essentially especially once these start getting more complicated, I think coming off to the side can be helpful. Yes, you are going to have all these rules memorized, but it's kind of the idea where you should be using them so often that they kind of just memorize themselves. But yes, you will have to have these committed to memory for your exam, which is coming up on the 21st. So not next week, but the week after. Not this coming week, but the week after. In 2 weeks. Anyway, so what's my f value? That would be x, and then g would be x squared. So now we have to find the derivative of each one of those two pieces. Derivative of x is 1. Derivative of x squared is 2x. Now that I kind of have all the pieces, I can just kind of plug them into that f prime g plus fg prime. So we have that the derivative would be our f prime times our g, so 1 times x squared, plus f times g prime. If I were to simplify this a little bit, I would get x squared plus 2x squared, which would be 3x squared, which is great because, again, that's kind of what we're expecting that to come out to be. So that's how product rule works. You kind of just have to find all the pieces and then plug them together, and all of the pieces can kind of depend on the other rules. So I'll hold on for 5 seconds before we do number 2. All right, so I have to scroll down past the rule, but hopefully we kind of got the idea of it. So for number 2, again, I'm going to come off to the side and I'm going to kind of find all of my pieces. So what's my f? That would be x squared and then e to the 2x. So the derivative of x squared, bring the power down, subtract 1 from the power, you get 2x. And then we have an e to the kx rule here, which again, remember, is technically a chain rule. So we would have e to the 2x times the derivative of 2x, which is just 2. E to the kx rule, that essentially does the chain rule for us for that one. And now that I have all my pieces, I need to put them together as f prime times g, so 2x times e to the 2x, plus f, so x squared, times g prime, so 2e to the 2x. Leave it there if you want to. Personal preference, I like to put all the constants in the front of the term and the e stuff in the back, so I would just rewrite that second term, but again, that's my own personal preference. You don't need to do that. Just for the sake of kind of giving a preview of some of the simplification that is going to make our lives easier in the next chapter, I'm going to take this the tiniest step further. Look how each one of these has a 2, has one singular x, and an e to the 2x. That means, so I know I just like essentially underlined everything, but so essentially we could pull out a 2x e to the 2x out of both of those terms. That first term, I would essentially just have 1 if I pulled that out, because remember, if you pull the whole entire thing out, you kind of need a placeholder. And then if I only take one x out in the second term, I would be left with just one singular x. So if I factored out the common pieces of those two terms, I would be left with this. Again, this is kind of, for the next chapter, this step would be helpful. But again, at this point, it's completely not required. But anyway. So now I want to jump up to number 5. I want to get a quotient rule in here before, because we need to jump around a little bit today. So let me scroll back up to get the quotient rule back in here. Let me leave this up for 2 more seconds. And essentially, we're going to do this one actually in 2 different ways. Let me zoom in a little bit. There we go. So the first thing we could do is we could do it just as a quotient rule. And similarly to product rule, I like to just kind of get all my pieces together and then just put it together in the rule. So what would our f prime be? It would be 2e to the 2t. And what would our g prime be? It would be 1. But then here for our quotient rule, we kind of have this extra piece of g squared. So take the original g and tack a squared on it. So t squared. I'm kind of remember that I want to do another. I want to do this again in a minute. So that means that our full derivative. So we need f prime times g. So 2e to the 2t times t minus f times g prime. So e to the 2t times 1. All over g squared, which was t squared in this case. So again, we could also do this in a different way. For some reason, there's a group of people that refuse to use the quotient rule. I don't quite get it, but it's a thing you can do if you want, because essentially what we can always do, it might make your life more difficult because doing this often brings in a chain rule. In this case, it's not, but in a lot of the more complicated ones, like even just number 6, if we were to do this process, you would then have to add in a chain rule. But just so that you can see it in case you like this way and you'd rather do it this way, you can always rewrite a quotient as a product by taking that denominator and putting it to the negative first power. Now again, in this case, since it was just t in the denominator, it comes out kind of nicely because it's just t to the negative first. But once you have something more complicated in the denominator, you'll now have a chain rule in your product rule. But we could do it this way with a product rule now, where our f is e to the 2t and our g, that looks like a really gross t, is t to the negative first. And our f prime would be 2e to the 2t, and our g prime power rule would be negative 1t to the negative second. So then our full derivative, I gotta be careful or else I'll run out of space. F prime times g plus F times G prime. Notice that these two answers don't quite look the same. If we were to do a lot of algebra on either one, we would be able to find the other. So they are equivalent, they just might not look the same. But that's essentially two different ways you can do the quotient rule. And again, that always can be done. It's just that sometimes it gets, in my opinion, more complicated because then you have a chain rule inside of a product rule. But if you're deciding that you want to be one of those people who absolutely refuses to use quotient rule and just wants to use product rule always and forever, you can go ahead and do so. That floats your boat. I personally think quotient rule is not as bad once you get the hang of it. But anyway, for the next one. So this one, now I'm just going to do it the one way, and I'm going to do a quotient rule way, because I think that's most of the time what people decide to do. So we're going to have F and G. We're going to need F prime. We're going to need G prime. And we're going to need G squared. Sometimes I forget to write G squared if later in life we're doing a quotient rule and I forget to write the G squared. I just always remember to put it in at the very end, so sometimes I forget to put it like in my little chart. But anyway, so our F is our 5q squared, and then our q cubed plus 1. So what's the derivative of F? Well, that 5 is going to come along for the ride, then we're going to bring the 2 down, so we're going to get 10q to the first. Then if we take the derivative of q cubed plus 1, we're going to have 3q squared plus 0, so I'm just not going to write it. And I need to move this over a little bit or else I'll run out of space. G squared. So for G squared, pretty much all the time, just tack a squared on it. Don't worry about simplifying it as much. If it's something simple, like the denominator is just t or t squared or something like that, and it's simple to simplify it, go right ahead. But with something like this, like, I ask you to expand that out at all. So at this point, we just need to now kind of put the pieces together. So we've got F prime times G. So we've got 10q. Now, since this is q cubed plus 1, since there's addition, please put it in parentheses. So if any of your pieces have addition or subtraction in them, please put them in parentheses, or else you're going to be wrong. So our F prime times our G, and then we subtract our F times our G prime. What am I writing? G prime. All over. Oh my goodness, why do I keep writing 2? All over G squared. You could simplify that up a little bit. I've essentially run out of space, so I'm just going to leave it there. But you could technically multiply the 5q squared and the 3q squared to get 15q squared. You could distribute that 10q and even go a little bit further after you do that. But again, at this point in time, simplification isn't really necessary. Any questions on either of those? We're going to jump to very similar types of things, but I'm going to save these last 4 for Monday because I want to get to, there's a couple questions that are similar to ones that you'll see on your Wiley homework. So I want to talk about those. So if there's questions on any of these, please let me know before I move on. I'll give you like 5 seconds. Okay. So we'll come back to these when we get a chance, probably on Monday. But I want to jump down here because there's some questions like this that pop up on your homework. And you might not realize that you technically have the tools you need to solve them. Now, nudge, nudge, wink, wink. I really like these types of questions. So take that as you will. So essentially what these are doing is they're kind of forcing you to remember these rules generically and to be able to use them in a generic fashion instead of just with the equations. So essentially what we're doing here is we're being asked for h prime of 1, where we're told that h of x is going to be equal to f of g of x. Also, let me remind us of our chain rule, because because that's what it's going to use here. So our chain rule tells us this. Oh no. Ah. So essentially what we need to do here is we need to find the derivative of h kind of generically using this chain rule. And then we're going to plug in 1 and we're going to essentially use these values that were given to solve it. So what does my chain rule tells me? It tells me to take the derivative of the outside function, leave the inside alone. So this one's nice because it essentially mirrors the chain rule. But part B of this one will be kind of the opposite, so we'll need to be careful. But it says take the derivative of the outside, leave the inside alone, times the derivative of the inside. So well, what if I want to plug in 1 there? I'm going to replace everything with a 1. Every x with a 1. And then I'll breathe for a second because I remember that you guys don't necessarily write as fast as I do. So then what we do here is now we essentially use these values we're given. Now remember way back when we talked about compositions for the first time, it's always working inside out. So the first thing I should really focus on is this g of 1 because that's kind of the inside of that first term. So what is g of 1? Well, g of 1 is 0. So I'm going to replace that with 0. And then I need to look for f prime of 0. Well, that's coincidentally also equal to 0. And then I need to look for g prime of 1, which is 1. So try to get some colors in here so that that's kind of clear where these numbers are coming from. 0 times 1 is, of course, 0. Oh my goodness. So essentially what we did here was we took a very generic derivative. We wanted to plug in a value, and so we used the values that they gave us to be able to replace the correct things to find the full answer. So say, and I'm kind of pausing in case there are questions, so of course stop me if you need me to, but say we want to do part B, where now we're essentially just switching that composition around. Oh my goodness. My notation on this is really bad. K of x. There we go. So the first thing we would need is a very generic derivative. So this is a chain rule. What does the chain rule tell us? Derivative of the outside function, so g prime, leave the inside alone, times the derivative of the inside. So it's still following the pattern of the chain rule, it's just now that the letters aren't the same, so it's not quite as easy to just rewrite it. And now I want to plug in 1 everywhere I see an x. So f of 1 times f prime of 1. Need a new color. So once again, compositions work inside out, so we would need that f of 1 first. Get g prime of 1. I should have made these have better values. And then we want g prime of 1, which was already laid out. And then I need another color, orange. And then f prime of 1. Apologies for anyone who's colorblind and this doesn't help at all. But we have 1 times 3 is 3. Questions, concerns on any of that? Before we move on, I'll hold on for like a few more seconds in case people need to catch up. All right. So again, I really like these types of questions. We'll do a couple more of these. We might get to them today, but probably on Monday, because I want to skip down to a similar thing, but slightly different. So we'll come back to this one, but this one is essentially doing the same thing, but now we have a product and a quotient rule instead of a chain rule. But I want to come down to this similar idea, but now we don't have just the set values, we have a graph, because there's also a couple of these on your homework. The Riley one. Because we just did a couple with chain rule, I want to do 3 and 4. Again, if we have more time, we'll go back to some of the other ones, but I want to make sure we can get kind of a decent amount of, I don't know what I'm trying to say. A decent, nope, I don't know what I'm trying to say. Anyway, let's do number 3. So say I want h prime of 2 if we're defining the function h to be f times g. So let me come over here, because I don't have a lot of space underneath that. And let me find the generic derivative first. Well, again, now these ones are kind of nice because the f and the g are essentially going to mirror exactly the product and quotient rule for these. So what does our product rule say? It says take the derivative of the first function times the regular second function plus the regular first function times the derivative of the second function. Now I'm going to pop back over here. And so if I want that evaluated at 2, well, then I just replace all the x's with 2, of course. So g of 2 plus f of 2, g prime of 2. So the difference here is that we're not just necessarily just given all the numbers just written out nicely for us. We kind of have to find them. But notice that we kind of have 2 different types of values going on. We have derivative values. You have f prime of 2 and g prime of 2. And then we have kind of regular values, g of 2 and f of 2. So let me start with the regular values first. Let me find g of 2 and f of 2 first. So if I want to find the, oh, and I always forget that these graphs aren't, for some reason, labeled. I could have sworn I labeled them, but apparently I didn't. So that blue one is f of x, and the orange one that just comes straight down is g of x. So say I want g of 2, let me go over to x equals 2, go up to the function. What's g of 2 equal to? G of 2 is going to be equal to 6. So essentially I can replace this second value in the thing that I need with 6. And then if I want f of 2, only go over to 2, but then up to the function f. Well, at f of 2, I'm up at 4. So I can replace those 2 values with essentially just the y values from the function. Now the f prime of 2 and g prime of 2 are going to take a tiny bit more work because those are derivative values, and remember the derivative tells you slope. So here we essentially need to figure out what the slopes of kind of all these 3 pieces are, because we've kind of got 3 pieces. F of x is kind of made up of 2 pieces, and g of x is just 1 piece because they're just straight lines. So let's go ahead and find the slopes of all of these line pieces, and then we'll figure out which ones we actually need. So let's look at this first piece of f of x. So if I want to find the slope of that, essentially if I start here, I pop over, and then I can pop up 1, 2, 3, and 4 before I hit the function again. So I went up 4. But we need to be careful because the x values increased by 2, so I went over 2. So that would mean that the slope of this line, this part of the line, is equal to 2. 4 divided by 2. Rise over run. And then what about the second part of f? Well, it's essentially a straight horizontal line, so the slope of that is going to be 0. And then what about g of x? Well, g of x is just one straight line, so it's going to be the same slope everywhere. So if we start, kind of at the top and we jump over 1 step, and then we go down 2 steps. So we went down 2, but again, the x values changed by 2, so it'll be -2 over +2, so the slope of this entire line here would be -1. And remember, if these weren't straight lines and they were just functions, we would be looking at the tangent lines. But since these are straight lines, their tangent line is going to be that line. So I know there's one on your homework. It's multiple choice though. That's not linear, but then there's also another one that is linear. But anyway, so now we want f prime of 2. Well, at 2, you know, the function f is kind of in that first piece, and the slope of that first piece was 2, so f prime of 2 is going to be equal to 2. And then what about g prime of 2? Well, if I'm at g prime of 2, well, g is kind of nice because it's the slope's the same everywhere. But at that specific point, we're going to have a slope of -1. So g prime of 2 is -1. I've run out of space, so I kind of have to go backwards. 6 times 2 is 12, minus 4 is 8. So the answer to that question would be 8. So it kind of is similar to the last one we did, where we have to kind of find a very generic derivative and then plug in a value. But here we kind of had to go a step further and actually find those values instead of just using them that we were given. So we've got about 15 more minutes, so I'll just keep going over things until we're out of time. So let's go over number 4. And again, as always, stop me if you need to. So here we have k of x is a quotient. So the first thing I need to do is find the generic derivative. And again, this one's kind of nice because the functions work out that it's essentially going to look exactly like our quotient rule. So the derivative of the first times the second plus minus, because it's quotient rule, the first times the derivative of the second divided by the second all squared. And then we want to put a 6 everywhere. We see an x, so k prime of 6 would be f prime of 6, g of 6, minus f of 6, g prime of 6, all over g of 6 squared. Once again, we kind of have some regular values. So we have g of 6 and f of 6 and also g of 6 again in the denominator. And we have derivative values. Oh, I did the colors backwards the way I did it last time. Let me make it similar to the way I did last time. So we have the regular types of values. And then we have the derivative type values of f prime of 6 and g prime of 6. So we know all of the slopes, so essentially the main thing we need to figure out here is actually what g of 6 and f of 6 are. So at 6, we're going to have that g of 6 is going to be equal to 2. I don't know why I put a parenthesis there. And f of 6 is going to be equal to 8. So we essentially have all the values, we just need to put them in the right spots. So we've got f prime of 6, well at 6, the function f is in that kind of horizontal piece, so the slope's going to be 0. Times g of 6, which we just found to be 2. Minus f of 6, which we just found to be 8. Times g prime of 6, so at 6, g of x has a slope of -1, so -1. All over g of 6 was 2, so 2 squared. So we'll have positive 8 over 2 equals 4. Oh, sorry, I didn't square it. Positive 8 over 4 equals 2, because 2 squared is 4. Any questions on where any of those values are coming from? Why I did anything, the things I did, any of that jazz? Going once, going twice. All right. Okay. So 10 more minutes. So what other ones do I want to do? Do I want to go back there? Do I want to keep doing these? Let's finish off this problem. So let's do 1 and 2 that we didn't hit from this problem. We'll just stay here. So, well, now I'm kind of out of space. So let me, come on, do the thing that I want you to do. Stop it. I'm gonna zoom in a little bit so that I can write a bit smaller. And I'll do this. So for the first one, now we're kind of back to using the chain rule. Yeah, I can't really keep those y values in there, but it'll be all right. So we'll have that the generic derivative here is going to be essentially f prime of g of x times g prime of x. Derivative of the outside alone times the derivative of the inside. So if I'm looking for h prime of 1, I'm looking for f prime of g of 1 times g prime of 1. So actually I do need to zoom back out because we need those y values. Oh well. Work inside out. So the first thing I should find is that g of 1. 1 is kind of right here. So if I go up to the function g of 1 is going to be equal to 7. So now I need f prime of 7. So what's the slope when x is 7? Well, when x is 7, it's going to be essentially on that straight line piece. So the slope of f is going to be 0. And g prime of 1, the slope of g at 1, since it's the slope of g everywhere, is it's negative 1. 0 times negative 1, 0. Let me clean up this graph a little bit. Too many things floating around. Whoops. And now we'll get rid of that too. So the next one, if we want k prime of 2, I'm going to try to do 2 steps at once. I'm going to write the generic one, but also replace the x values at the same time. But the derivative of g of f of x would be the derivative of the outside, evaluated at the inside. So I'm going to write f of 2 since I'm going to want that eventually anyway, times the derivative of the inside, so f prime, and specifically f prime at 2. So I just didn't write the generic one this time because I'm vastly running out of space. I should have put a lot more space on this one. Again, for compositions, work inside out. So the first thing we would want to look at is f of 2. So f of 2 would be 4. Then we want our derivative values. What's g prime of 4? G prime of 4 is going to be negative 1, because the slope of g is essentially negative 1 everywhere. And then f prime of 2, that's on kind of that first part of f of x, so that's going to have a slope of 2. Negative 1 times 2, excuse you, pen, is negative 2. Clean that back up one last time. Questions, concerns on any of that? We've still got 5 minutes, so I'm going to force us to do one more. The more we do today, the farther we can get on Monday. And we need to start getting farther, so. All right. So again, that's how these kind of go, is that you just take the generic format of the derivative, and then if you need to find the values, you do so. If you need a derivative value, you find the slope. If you need an original value, you just find the y value, and you plug things in. So to end today, this will be the last one we do. I'm going to go back up to our generic ones. I should not say generic ones because those ones were super generic, but kind of our formula ones, not formula, even equation ones, I should say. And we'll do one more of these, and that'll end us off for today. So let me look at number 3. So we've got a product rule here. Now, the other thing with these is a lot of people will wonder when to use chain rule versus when to use product rule. You kind of want to look and see how many variables you have floating around. So in this one, I have a t cubed and that t inside the natural log. So since I kind of have two completely different occurrences of the variable t, and they are multiplied together, those two terms, I'm going to use the product rule. If I only have kind of one occurrence of, well, I should be careful there. As opposed to, I should be careful with my wording here. Let's say we look at this one really quick, the 3x cubed minus x to the 5th. Technically, there are two x's in there, but they're being subtracted and then all taken to a power. So you want to look at essentially how many variables you have and also how are they connected. If they're connected by addition or subtraction, it's not going to be product or quotient rule. It's either going to be a generic rule or chain rule. But if there are more than one variable and they're connected together with multiplication or division, then of course that's going to be a product or a quotient rule instead of a chain rule. Hopefully that made sense. So anyway, this one's going to be a product rule. So let me do my little pieces here. So we've got t cubed and ln of t plus 1. So we've got a tiny chain rule in here now. So we have a chain rule inside of a product rule. So our f prime, derivative of t cubed, bring the power down, subtract 1 from the power, 3t squared. And then here we have a kind of tiny chain rule going on. So we have the natural log of something. So we have 1 over that something times the derivative of t plus 1. What's the derivative of t? It's 1. What's the derivative of 1? It's 0. So that kind of whole thing kind of goes away, but I'm going to rewrite it like this and then just say that this is equivalent to just 1 over t plus 1. So then the full derivative, f prime times g plus f times g prime. If you want, you could rewrite this, whoops, with the t cubed in the top of that fraction, but completely unnecessary. All right, and I'll go ahead and I'll stop there. So you should be able to do all of your Wiley homework. Remember, your Wiley homework is short because you kind of have that extra practice that's on Blackboard. That is highly suggested you try some because they're ones like these that are on the screen right now. And Wiley, the reason they're not on Wiley is because Wiley literally does not accept correct answers for those. I don't know why. So I wasn't about to do that to you guys. So there's the extra practice on Blackboard. Remember, all of the answers are there. All of the work is there. You will want to at least go through a subset of it, which again is why your Wiley is shorter, because as I kind of mentioned earlier, you will need to have these rules memorized. And really the best way to do that is just keep doing them, because the more you do, the more they stick in your head. So that's the thing. So feel free to stick around if you have any questions really quick. Otherwise, have a really great weekend, and I will see you on Monday. Yeah, stop the recording now.